Hello everyone, myself Forum Makwana, Assistant Professor of EC Department at FJ Institute of Engineering and Technology. Welcome to the session of Satellite Communication. In this subject, first of all, we are going to start unit number 1, that is Introduction to Satcom as per the GTU syllabus. In today's session, we will see, first of all, what do we mean by satellite? What is the history of satellite, parts, how it works, on which frequency the satellite is going to be operated, what are the advantages, disadvantages, and on which path a satellite is going to be rotating around the earth, that is called the orbit, and different types of orbits. First of all, what is satellite? Now, a satellite is an artificial body which is placed in the orbit which is moving around the earth. As we can compare that a different planet is rotating around the sun, right? So, the satellite is an artificial body which is placed in the orbit around the earth, or we can say moon or another planet, in order to collect the information, that is in the form of communication that we are going to establish. So a satellite technically is a station that is placed in the space. For which purpose? It is used for the telecommunication, radio, television signals and different other purposes. This is the image of satellite, that how it looks. As we can see that it has a different part that we will discuss into the next slide, that what different parts are there. So we can say that the most of the satellites have a transponder. Now what is transponder? It can be have two types. We can say that the transponder can receive the signal and reflect back to the Earth station, and it can receive the signal from the Earth station, amplify it and retransmit it back to the Earth station. So we can also say that a satellite is broadly classified into two categories. First one is the passive satellite and second one is the active satellite. Now what do you mean by passive satellite? Passive satellite means it will going to receive the signal from the Earth station and it will reflect back it to the receiving Earth station. As we can see that this is my transmitting Earth station, this is my receiving Earth station, and satellite is in the space. So transmitting Earth station is going to transmit the signal to the satellite, right? And that signal is nothing but reflected back to the receiving Earth station. That is, that signal is not going to be amplified by the satellite. That is called the passive satellite, right? And if it is going to be amplified, then it is called the active satellite. Alright. Now we can say that the active satellite is further classified as the non-geo satellite, that the satellite which can be in the LEO or in MEO. Now what is LEO and MEO, that we will discuss in the last topic of this today's session. Second is the geo satellite, that means a geostationary Earth orbit. The full form geo is, right? Now, as we have discussed the definition of satellite, we are going to start. What is the history of satellite? As you can see from over here is, this is the Sputnik 1 and this is the Aryabhatta satellite. So who has already invented this Aryabhatta and Sputnik 1? So let's focus on the history of satellite. So the first artificial satellite is this Sputnik 1, which was launched in 1957 by Russia. So the first active satellite is, it was launched in 1962. Okay, but that name was Telsat. So this Aryabhatta satellite, as we know, that Aryabhatta satellite is the satellite which was launched by India. As India has totally 118 satellites since 1975, organized by Indian Space Research Organization, because it is the company which is responsible for the India's space program. So ISRO has created a new record by launching a 104 satellite in one go, right? So I can say that out of this 104 satellites, only 3 of this were the Indian satellites, right? So the first satellite launched by India was the Aryabhatta, this one, okay, in 1975 of 19th April. So the first satellite launched by India was Aryabhatta, and the world's first artificial satellite is the Sputnik. Alright, Sputnik 1, which was launched in 1957, right? Now, as I have shown you the image of satellite, now we are going to focus on what are the parts of satellite. See, you can see over here that this is our satellite. The blue, the circle one is our Earth, right? So we can see over here that there are different parts, like the rectangular one is the solar panel, which is used to provide a power supply to the satellite. These two are the antennas, this one and this one. So these two are the antennas which is used for transmitting and receiving a signal to the Earth station. Alright? Or inside this box, what will be there? So inside this satellite, it includes fuel tanks, batteries and onboard processor, which is used to process a signal which was received from the Earth station. Okay? So these are the different parts of satellite. Now how this satellite is going to work? So first of all, we are focusing on the basic diagram, that this a half circle shows this is our Earth, this is a receiving Earth station, and that was a transmitting Earth station, and the satellite will be in the space. Now, a transmitting Earth station will going to transmit a signal to the satellite. So that signal is known as the uplink signal, right? And the signal is going to be processed and down converted by the satellite. Now what do you mean by down conversion? That we will focus later on. And that signal is going to be retransmitted back to the receiving Earth station. So the signal which is going to be retransmitted from the satellite to the receiving Earth station is known as the downlink signal. Now the question is, what are the frequencies for uplink and downlink? Whether it should be same or different? Reason is, the uplink and downlink frequency must be different, and uplink should be higher than the downlink frequency. Why? Reason is, first of all, both should be different, because if it is not different, then that two signals are going to produce interference. Okay, so for that reason, our uplink and downlink frequency must be different, and uplink must be high compared to downlink. The reason is, as the frequency is going to increase, the requirement of power will also going to increase. So the frequency is directly proportional to the power. That means if the frequency is high, we need to transmit the high power. And if we want to transmit a high power, we need to use a gain of or amplifier of high gain. Alright. So it will cause my circuit to be bulkier, and it will also increase the cost of my system. So what we can do is, we are going to implement that high gain amplifier at the Earth station. If that amplifier is going to be mounted in the satellite, then it will also cause my satellite weight to be increased, and it will cause a difficulty in launching of satellite in the space. That's why, for that reason, we are going to make the power, or we can increase the power of transmitting signal at transmitting Earth station by using a high power amplifier which has a high gain. Alright. So for that reason, uplink frequency should be higher than the downlink frequency, because we are able to transmit the high power from the transmitting Earth station. Alright, and as receiving at the receiving Earth station, downlink frequency is lower. Why? Because we are not able to generate that high power at the satellite, because that high gain amplifier was not mounted in the satellite. Alright, so that we need to down convert, we need to decrease the frequency which is going to be transmitted back to the receiving Earth station. Alright, so both the frequency uplink and downlink, both should be in the form of gigahertz range. So the satellite will receive the signal, and after processing by the transponder, it retransmits back to the receiving Earth station. Alright. So that was the diagram, generalized diagram of how the satellite works.